We're Team EMech. My name is Michael Lorenzo. This is Eduardo Garcia and Francisco Iriarte. And Dr. Basil is our advisor. We'll be doing magnetocaloric refrigeration. All right, why are we doing magnetocaloric refrigeration? Currently, the way refrigerators work is that they use a gas that is compressed and expanded in order to produce a refrigeration cycle. The problem with this is that these gases produce chemicals that are harmful for the ozone layer. So we're attempting to remove the need of these gases by using a solid material. These materials are called magnetocaloric alloys. Dr. Basil is doing research on these materials in order to produce materials that give you a greater change in temperature. We will be working alongside with the Ames Laboratory in Iowa, seeing as they have done a lot of research on the topic, and they currently have a working refrigeration system using magnetocaloric materials. They do a lot of work with a material called gadolinium. This is a sample of that material. And Eduardo Garcia will be presenting the proposed design.
Alright, so how does the magnetocaloric refrigeration work in respect to a classic refrigeration cycle? Pretty much, you still have the adiabatic process. So you can see here is a regular refrigeration cycle. This is the cycle of the magnetocaloric refrigeration. Pretty much, it goes through its compression right here. And that would be the same as the adiabatic process of the material passing through a magnetic field. And then here, the magnetic poles align in the material. Then that heat is rejected. That's why you see T plus change in temperature. The heat is rejected. But with that heat rejected, the magnetic poles are still aligned. So when we take it out of the magnetic field, what that's going to do, it's going to want to pull heat. So it's going to cool, from the heat exchanger, whatever we would like to cool. So pretty much it works in the same cycle as a classic refrigeration, except we're getting rid of the chlorofluorocarbons. This is one of the designs that we have. Pretty much, this design is subject to change, but pretty much here you see the main component. Inside here is where the magnetocaloric material would move forward and back in a reciprocating motion. This is the magnet with thermoelectric plates right here. So the thermoelectric plates would be what do the heat rejection, the initial heat rejection. So the material moves in. Right here, so we have a constant magnetic field. It rejects the heat, then moves back into the cold side heat exchanger, where we flow water through here, and that would, the material will pull the heat away from the water, which gets pumped in through a refrigerator, and that would produce a cooling effect. Next. And Frank will present the challenges of this project.
So one of the main challenges in this project is to construct an apparatus that is small enough and versatile enough so that we can change the materials in them. As I said, as we stated previously, Dr. Basil is currently working on producing different alloys so that we can be able to test them with our apparatus. Also, one of the things that our design requires is the use of other disciplines such as electrical engineering. Next slide. One of the benefits that as stated previously, one of the benefits that we have in our project is that we eliminate the use of CFCs. There's no need for harmful gases. We are reusing a specific type of material in order to refrigerate a system. This apparatus is primarily, we will be using low energy consumption. So this means that we have less resources. And right now, GE currently is involved with this research, and they're developing new systems of this type. Next slide. And here's our timeline and cost. The anticipated project budget is $5,000. Our projected cost is $4,000. That is also assuming that we optimize it as much as we can. And we estimate about 320 hours of human work. Next slide. Any questions?
Good.
I think you should be using bigger fonts for your timeline. It's not easy to read from here. I hope.
Okay.
Yeah. Bigger fonts.
So who's funding that budget?
Dr. Basil's trying to get us funding.
Oh, okay. That's a big number.
Yes.
He's trying to get us some, at least he told us he would try and get us at least $5,000 so we can go out to Ames Lab and, meet with them and, have a more in-depth experience with them and see what they're doing and kind of have more of an idea of what's going on.
Is Ames Lab not a potential funding source?
I'm not sure exactly what he's working on, if he's working with them trying to get funding from them, or I'm not sure who he's trying to get funding from. Pretty much he told us, I'll try and get you guys about $5,000 for the project.
All right.
Any questions? Okay, thank you very much.
All right.